Here is a short slideshow to introduce you to the concept of 100% integrated fixture design. It will explain how to use 3D CAD to improve fixture design and performance, which increases the visibility of the fixture design to engineers and technicians. How can we obtain complete visibility of every detail of fixture design? We can do this by adding IDF files to the existing information package that you provide for us to construct your fixtures. If you obtain pre-release versions of the files for the unit under test before you've finished designing your board, we can plan the fixture hardware around this in 3D. We can then show and discuss any issues with the fixture design before you've released the board for production, so that we know if any changes are needed with the fixture design. We can decide how to address any of these issues with anyone, be it a customer, a subcontractor, or somebody actually on the production line who's using the fixture. We can then update the design of the fixture when the unit under test is released to production. This means we are only involved in updating. We're not completely redesigning the whole unit again. We could then review the final design of the fixture and agree that it's ready for production, or there's still some issues. When we're happy with the design, we can release a fixture design for CNC drilling and machining immediately. We can reduce the need for a gold board to start the fixture build, because IDF files will give us a 3D model of the unit under test. We start the fixture design with the pre-release files before the unit is released for production. This gives us time to plan every detail and refer back to you, the customer. The time taken to update the fixture design is much less than starting the fixture design only when the gold board is ready. 3D allows us to integrate everyone involved at every level, so there are no surprises on fixture delivery. We can improve the fixture documentation for maintenance by these means. Here is a sample board. I can't actually show you the unit under test that I'm using to construct a fixture, so I'm showing you this instead, which is just a sample board that was produced about 10 years ago. You can see that I have height and positional information everywhere on every component. I also know the names of the components, so I can work out which one needs test jet or LED detection or any other kind of issue, such as pressing a switch, which you'll see on the next fixture. So in every case, I'm able to see the board, and the height and position, all dimensions can be defined. Now let's look at a fixture that was designed in this way. We can see that we've got a fairly detailed design here. If I zoom in on this area, you can see that I've imported a drill file to this part. I'm going to open this part to show you it. You may say, what is the value of this? Well, the value is that this 3D model is actually engineering data. It's not a picture. Using CAM, computer aided manufacture, I can analyze this board and decide how I'm going to machine it. In doing so, I will create a program to actually drill all the holes in the plate and then to machine things such as the recesses here for the seal track, for a vacuum seal, and for the test jet here. That means that I don't have to draw this board, and there is no delay to put it into production because I have all the engineering data that's needed. Now, going back to the complete fixture job, you can see here that there is an issue because quite clearly I have a test jet plate here and I have two probes that wants to come up through the plate. Obviously that cannot happen, so there is an issue with this design, but because the unit is not in production yet, we have the opportunity to discuss it with the customer and decide what can we do. Of course, if we don't have to trouble a customer, we will not do so. Here as well, I have defined the position for the PCB stoppers, which is another part that would be planned after your gold board is ready, but in this case we can plan it before and simply make changes if anything has moved, if any component has moved on your final design. One can see on the hold down gate that I have quite a lot going on, but I've defined all the press rods positions as well. This means that my top plates can similarly be shown as engineering data in a 3D model. So I can also drill and machine this immediately once the design has been agreed. You see here that there are cylinders which are pneumatic cylinders. These are used because the board in question has a switch on it and the customer wants to press that switch and test that something has happened to it. There are also 4 LEDs on the unit under test, and we're going to use LED detectors to detect these. You can see here that I've made available holes exactly over where the LEDs are, and if those LEDs move on a new unit, these holes will move with it. They will follow the component because it's been designed in that way. This is sometimes called concurrent engineering. What it means is that the design is based upon another design and can be updated almost immediately. So to plan out a complex fixture like this with 8 boards on it only when the board is available is obviously a nonsense, because there's so much work I can do up front to ensure that when your board is ready for release, if it was on this unit, we'd be able to start work within 1 day, and we'd be able to machine all the plates very quickly because they've been designed in this way. In this design there's a further complication where we're actually using a small microphone, which is this component here, to detect a sound from the board. And unfortunately this microphone will require to have an amplifier. So what is this going to look like? Well, I'll show you now. I've removed, hidden from view, the 3070 alignment plate. Let's zoom in here. I've created an overlay for the PCB that will contain the amplifier for the microphones. There are 8 units under test, so there are 8 microphones, and I've been able to position these within the fixture in such a way that it's not going to interfere with any of the tester resources, which is always an issue, especially when you're trying to design something complex when there is no more time, because the minute your gold board is ready, there is no time. And we like to make your products available when you need them. So this would help us to assist you. If I hide this component, you can see where I've mounted the amplifier boards. They're not going to clash with anything, and I want to prove that to you now by showing you the 3070 alignment plate in position. And if I zoom in, one can see here that I've made the best use of the available space. So we hope that you see the advantages of using 3D design, because we intend to use this on all fixtures from now on, which will be of great benefit to everyone, because there should be no surprises. We can show you your fixture design with an online meeting so that people can be involved anywhere in the world at a mutually convenient time to review the design, highlight any previous issues that might have come up, and ensure that we eliminate those going forward by planning your design and showing it to you before we make it. The best thing yet is that although this project is not urgent, I know that we have done 99% of the design work, and we are ready to press the go button. Should be within 24 hours we're actually able to start the drilling and machining, and probably complete it the same day. So it gives us an excellent opportunity to improve the performance of the fixture, because everyone will be taken account of, and everyone will be able to observe the design and point out if there are any issues that they have with the design. Documentation will be straightforward and easy. Bill of materials is available, which means recommended spares lists can be provided, and if necessary purchased at the same time that the fixture is purchased. So thank you for your attention, and we hope to serve you soon with this new technique. And all you need to obtain are IDF files, which we will explain to you by sending you some documentation, which will explain what an IDF file is, which CAD systems it's available in, which is nearly all of them is an intermediate data format,